Scientists now know the cause of warm weather, rain, and most things on Earth. It's a gigantic star in the center of our solar system. A star so important we gave it a special name. A star that deposits more energy onto the surface of this planet every minute than the human race uses in an entire year. This energy can be harvested, but at great cost and inefficiency, which is a shame because we rely on electricity, and this is causing problems as old methods of generation become expensive and pollute the environment. You might think that New Zealand's doing well to generate power from hydroelectric dams, but right now almost half the electricity used to power my computer is coming from non-renewable sources. That means that the energy equivalent of 2 kilograms of coal had to be burnt just so that I could work on this video. But in New Zealand we receive in excess of 2,000 sunlight hours a year. If we deployed market standard solar panels to the roofs of all New Zealand homes, then we would be able to generate almost all our power from renewable sources. Better still, if this move was accompanied by the development of new solar technologies, New Zealand companies would be well placed to take advantage of the solar manufacturing boom in China. Electrical current is the movement of tiny particles called electrons, the same particles that you find moving around in atoms. So, how can the sun generate this movement of electrons? Well, the fact that light can create an electrical voltage across a material was first discovered 150 years ago. When light hits a material, it interacts with the electrons in the atoms of that material. This interaction can have the effect of knocking electrons out of their atoms. But this is not much use unless all the freed up electrons are made to go in the same direction to form a current. This has been done for the past 60 years using semiconductors. If the right semiconductors are layered on top of each other, then electrons which are freed up by light are all forced to go in the same direction, forming an electrical current. The problem is that this requires large amounts of expensive semiconductor, and these devices have a maximum possible efficiency of only 30%. One of the reasons for this low efficiency is that conventional devices only use visible light. But the sun doesn't just create visible light, it creates infrared light as well. Possible solutions to harvest this energy include solar cells with many layers, and solar cells that use tiny clusters of atoms that behave in so-called quantum ways. I want to tell you about this research and how it could be used to craft a brighter solar future.